Good evening, sir. Good evening. Sir, I am audible.
Yes, yes. So we will just start in 2 minutes.
Okay, sir. Okay.
Okay. Okay. So good evening, everyone. So we are here for the last session of this course. So this is the NPTEL live session of week 12 for non-conventional energy sources. The course is taken by Professor Prathap Haridoss and from IIT Madras, and I am taking the live interaction session for this course. So today I am having slight cold, so just pardon me for that. So we'll start our session. And as my introduction, I am Lalit Bharti, a Prime Minister's Research Fellow in the Department of Physics at IIT Kharagpur. These are my email and LinkedIn profile URL. So you can contact me over there if you have any kind of suggestions, feedback, queries. So this is the last chapter of the course, and we will be covering questions based on supercapacitors, flywheels, and magnetohydrodynamics, energy generation. So basically, supercapacitors in electrical energy storage, and flywheels is from the mechanical energy storage, And then magnetohydrodynamics, this is also from the kind of energy generation and energy storage. We'll see few questions on that also. Then at the end, we will discuss few questions from the week 11. So let us start with the first question. So we have the question on magnetohydrodynamics. So the question says, the magnetohydrodynamic power generation uses the plasma state of matter. So we need to see, is it true or false? So for that, let us just discuss the mechanism of magnetohydrodynamics. So basically in that, we have magnetic, we have magnets. So we have two poles of a magnet. So you can see this is the north pole, this is the south pole. Then we have the plasma. Plasma is kind of a gas. So the plasma gases are still hot enough. These are quite hot. So enough to downstream from MHD or the magnetohydrodynamic generator to turbine for conventional AC power generation. So we have to follow the Faraday's law here. So basically, if we have a separation of charges and in presence of magnetic field, so this is the force exerted, this is the magnetic field. So we'll see the separation of charges, magnetic separation of charges with some velocities here. So we have the comparison between your regular generator or magneto-electric generator, and this is the magneto-hydrodynamic generator. So basically we have armature. This is the armature, and armature is basically we have multiple coils here and holes of magnet. So basically if we move this, if you rotate this, so you will generate a electric field. You will generate electricity by the varying electric field in the presence of a magnetic field. So this is similar to a reverse process of a motor. So in motor, you supply some electricity and you get the rotation of the armature. And here, the opposite is happening. But in magnetohydrodynamics, you have poles, and you instead of a rotating armature, you have a source of hot electrically conducting gas, or you can say that is the plasma. And due to the separation of charges, you will get the electricity at these electrode. One will be cathode and one will be anode. So this is the example or the mechanism of magnetohydrodynamic power generation. So the drawback is the plasma operates at a very high temperature, because plasma gases, it cannot be working at a normal room temperature. So we need high temperatures for this kind of systems. So the statement is true that yes, they use the plasma state of matter, or you can say these are the ionized gas. So these are being utilized in this magnetohydrodynamic power generator. Then we have the second question. It is on the conventional capacitors. So capacitor stores energy using ions. So there's a catch that this statement is false. So we will see why. So if they ask that supercapacitor store energy using ions, then it would be correct. But they are just asking the conventional capacitors. So we know how a conventional capacitor works, or what is the conventional capacitor. So conventional capacitor is basically two parallel plates of metal. So this is your first plate and this is your second plate. So basically two metal plates, they are separated with some dielectric media. So it should not conduct electricity. Then if you try to connect a voltage to this, connecting in these plates, positive at one side and negative at one side. So what will happen? So this plate will be positively charged and this will be negatively charged. So if you have the positively charged plate here, so it will attract the negative ions or the negative charges in the dielectric. Dielectric have the property, because we cannot use any normal conductor inside these parallel plates, because dielectric has the property of polarization. Whenever electric field is applied, it will not conduct electricity. So what it will do, it will just polarize the atoms inside, or molecules inside the dielectric media, but it will not conduct the electricity. If we use a normal conventional conductor, so what will happen? These positive charges will move directly to the negative charges, or the vice versa. Then it will be short circuited directly. But in case of dielectric, the negative charge will attracted by the positive, and as well as the positive charge will be attracted with the negative plate, and we will get a capacitance. So that is called the capacitance. So basically, the energy is stored as a function of, or the is in a form of separation of charges. So we already had this kind of separation inside the, but these charges inside the dielectric media, but due to the electric external field, so the charges got separated. So it is called the separation of charges. So capacitor works with the separation of charges. But if we have some kind of, if you tune the dielectric media, and if you put some electrolyte which is having ions, and if the ions are moving here and there, then it will be a supercapacitor. So we will see the difference between capacitor and supercapacitor. But as the introduction to normal capacitor, this is the this is the definition and the mechanism of a conventional capacitor. Then we go to our next question. It says, gas diffusion layer enables reactant from channel area to react land areas. So this is, I guess, from the PM cell or the fuel cells. Gas diffusion layers enable reactant to channel areas to react land areas. So I guess this is from the fuel cell part, and we had the gas diffusion layer in that. So basically, the use of gas diffusion layer is to provide paths or channels for the gases. So if this statement is like a, so this statement will be true in that case, that yes, gas diffusion layers enables the whatever reactants we have, so they provide a channel or path to reach the areas to react with each other.
So in this question, land areas. Land area means
Land area is, that is why I'm getting confused with from which part is this. If this is from the fuel cell, then this is correct. But land area is, I don't know, this question is incomplete or what. Gas diffusion layer enables reactors with channel areas to reach. Okay, we'll see this question later on. But I guess if this is from the fuel cell part,
okay, sir.
then
Yes.
this is the case. Okay. Otherwise, I'll see if the question is taken from where. Then this is the next question. This is basically on the flywheels. So what is a flywheel? This is kind of a mechanical energy storage device. So till now we have seen the electrochemical, chemical type of energy storage, energy generation, this type of devices. But now we are having a device or a system which stores mechanical energy. So what we have to see, what is the mechanism of this? So the question is simply, energy stored in a flywheel increases as the cube of angular velocity. So this relation we'll see. Just let us have a look on the mechanism. So basically what happens, you have a bulky rotor here. So this is a piece of metal, heavy metal. So you have in cylindrical shape, and the mass is quite high, or the weight is quite high for this. And you have a generator here. Or this is bilateral or dual, you can say this is a bilateral device which can be act as a motor and a generator. So we have seen already in this case, we see that this, if this is a generator, you can also use this as a motor with some very minute modifications. So here we have a device which can be act as a motor as well as a generator. So what will happen? So at the initial stage, this rotor is stationary, and whenever you need and you have the surplus energy, you need to store the energy in this device. So we will connect the electricity to the terminals, and this motor will start rotating. So this motor will be rotating at very high RPMs. So the at quite a high RPMs. So this motor is directly connected to the rotor. So what will happen? The rotor will also rotate. So it will start rotating, and the system is made up like this. If you just switch off these electricity supply, still it will be rotating. So what we need to consider, so this friction between this, because the rotation will be stopped if you have a lot of friction or the eliminating elements. So you need to remove this friction, as well as you need to remove the friction due to the presence of air. So for presence of air, what we have done, we have used this vacuum pump. So it is attached with this. So all the air inside the system, it will be just pumped out with this vacuum pump. So we will get a vacuum inside this chamber. So there is no friction due to the air. Then we have the magnetic bearings. So what is magnetic bearing basically? So if you have seen, if you put two magnets together with the same polarity, let's say the n pole together, those they will repel each other. So similar thing is used here. If you put the n pole here and nth pole here in both of the cases, or the south pole here, similarly, so they will repel each other. So they will work as, if you use the sufficiently strong magnet, so they will use as a buffer zone in between. There is very low or negligible or very, you can say the no friction will be there if you use a sufficiently strong system. So similar thing is here. Similar, the magnetic bearing is used here. Similar magnetic bearing is used here, because if we don't use this kind of bearing, if we use a regular bearing, then what will happen? This rotor will just stop rotating with the itself with its friction. So now we have eliminated, maximized, minimized the every type of friction. Then whenever you need the energy, you just connect this rotor again to the generator. Then this generator will generate the electricity. So basically, when you're supplying energy, it will act as a motor. It will rotate the rotor. Then whenever you need the energy, you just use this motor as generator, and it will generate the electricity to for your use.
Sir,
So we will use the, yes.
this rotor acts as a flywheels.
So this is the rotor, or this whole system is kind of a flywheel. So here we are using the electrical energy. So that is why you are just saying that the motor is used. If you are directly using the mechanical energy, so one system also can be, you are just attaching a kind of a belt here and providing mechanical energy direct to rotor. And whenever you need the energy, you use this mechanical energy to run whatever application you have. So that is the flywheel. But in case this is also flywheel, but the energy provided or the energy gained is in form of electricity. That is why we are using this motor. So it can be of different types, but the mechanism will be same. So the question is, energy stored in a flywheel increases with the cube of angular velocity. So for that, we need to see the relation of moment of inertia of this cylinder. So we know for a uh, this is not hollow cylinder. This is completely bulky cylinder. So for this, the moment of inertia is half I omega square. Basically, I is your moment of inertia. So the total energy is equal to half I omega square, where I is the moment of inertia, which is also gained by the for this case. For the case of solid cylinder, you have mr square, and omega square is your angular velocity. So the question says, is the energy storage cube of related with the cube of angular velocity? So we have seen that it is E is proportional to the square of angular velocity. So this statement is false. But now we know that energy stored in a flywheel is proportional to the square of the angular velocity. So this is a typical flywheel system. So these are mechanical systems. So if you compare the mechanical system with the conventional, either electrical or electrochemical or chemical, so their efficiencies are low, but the amount of energy stored is quite high. So one more example can be, if you have heard about a sand battery. Sand means a normal kind of sand. So what they will do, they will have a chamber like this, no rotator, nothing. So they will just put sand inside this. So sand is quite cheap, and you can make a very large tower of that sand. So you will put the sand, and whenever you have the electricity or any kind of energy, you will just heat this sand inside this, and you have a very good insulation outside. And whenever you need the energy, you use that heat to either directly use as heat or use as whatever. If you run a turbine, then you will get electricity. So although the efficiencies are quite low, because there will be a lot of losses due to the improper insulation, then due to the heating and cooling mechanism, but the energy stored or the energy densities are low, but the total amount of energy stored is very high, because you can make a very uh, let's say in kgs or in 1000 kgs of sand you can use directly. So you can make a very large size system. So the efficiencies are low, but the energy stored is quite. So that is also a type of energy storage system. Then we have a numerical question on the flywheel. So we have already seen that energy stored is equal to half mr square omega square. So the question is, a flywheel has its moment of inertia tripled and its angular velocity doubled. So what will be the energy stored in this case of that? It will be increased by which factor? So basically your I is replaced by third time of I or inertia, and your angular velocity is doubled. So you just put your I prime and omega prime square. You just put these values. So 3I 2 omega square. So it will be total 3. It will be 4. So it will be 12 I omega squares. And I omega square is basically your initial conditions or your initial. So you will get E prime will be 12 times. So the correct answer is 12. Then these were the few questions from the mechanical energy stores. Then we come back to the supercapacitors. So now here we are comparing the supercapacitors with the conventional battery. So the question is, batteries and supercapacitors are identical in performance characteristics. So no, these are not exactly identical. They both are kind of electrochemical device, but they have significant differences. So this is our battery. We have already discussed a lot of things in batteries, how the battery works. And this is your capacitor. So, sorry, supercapacitor. So we have seen. So what is different in a regular conventional capacitor to a supercapacitor? So we have changed the dielectric with the electrolyte. So in dielectric, we didn't have any moving ions, but here we have moving ions inside the electrolyte. First thing, the electrolyte is changed. Then second thing is your electrode behavior is changed, because in capacitor, let's say this is a capacitor, and this is your area is, if you use a 1 by 1 meter plates, let's assume you are using a very high, large size capacitor. So you have the electrode area or the parallel plate area of 1 meter square here, 1 meter square here. So your total area will be 2 meters square effectively. But here, if you use a electrode material which have a very high porosity, so let's say you use graphene. So graphene itself has a very high specific surface area. Specific surface area means if you see from the outside, you will see a simple 2D structure, sorry, 2D plane. So you can say this is the area of 1 by 1 meter. But as you go and you see from the inside the structure, so you will see at the surface, these are not flat or these are not plain. So you have very deep pores inside that. So in graphene, you have a 2D layered structure. So the surface area is very high and the pores are, it is quite porous. So the pores, if you can assume these as porous structures, so the effective surface area is very high. So for example, the theoretical surface area, specific surface area of graphene can go up to 2000 more than 2000, but just typical limit 2000 meter square per gram. So if you assume just a 1 gram of material, if it have this specific surface area of 2000 meters square, so it is a very large in comparison to your normal plates. So we have modified this electrolyte as well as electrode. So we have ions inside. So at the negative electrode, you will get positive ions attracted. At the positive side, you will get negative ions attracted. So basically, your efficiency or the performance is quite increased in case of in comparison to normal capacitors. So what happens with comparison to batteries? What happens? We have quite large energy densities in batteries. Energy density means the total energy stored. So these are energy densities are quite high. In case of supercapacitors, your energy densities are low because these are just separation of charges or the separation of ions in this case. So energy density, total stored energy is low. Here you have lot of, in batteries, you have lot of chemical reactions happening. So your energy densities are quite high. But your power density is low means these the energy, the delivery power, what a power density reflects. So power density means this energy density by the time means, am I am I connected?
Uh, yes, sir. Sir, once differentiate with a high power density and high energy density by definition and unit.
Sorry, can you repeat?
Difference between power density and energy density.
Yes, yes, okay. So basically, we have seen the energy density means the total energy stored, and power density means how fast you can deliver that energy. So P is equal to basically E by T. So if let's say you have 100 watts of energy, watts is power. So let's say you have a battery, you have a mobile battery of 1000 mAh. So one battery is completely discharging in 1 hour, and one battery is taking discharge time of 10 hours. So basically, your power will be 10 times lower than which is discharging in 1 hour. So same things happens here. So in batteries, you have many reactions happening. So your kinetics are low. So basically, it will take longer duration to discharge the battery. So the power densities are low. Although energy densities are high, but they will take a lot of time. So T is quite dominant. So T is quite high. So E by T will be small. In case of supercapacitors, they have their energy densities are lower, but they will discharge very fast. Similar to capacitors, they will discharge very fast. So their power densities are very high. So if we compare, the energy densities are high in battery, but power are low. In supercapacitors, power densities are high, but the energy densities are low. So here comes the application of these. So wherever you need high energy density, means you need longer battery backup or you need a higher storage. Let's say you need a in mobile phones, you need battery for running for many days. So you need a battery. But we need very burst of power. Let's say you are in a electric vehicle and you need a sudden energy whenever you are accelerating. You need sudden energy. So the supercapacitors can be used to provide sudden energy or just high power of high power at that rate. So supercapacitor can be used in that kind of devices. And if you need a balanced system, you can make a combination of batteries and supercapacitors. So whenever you need longer energy densities, so you can get it from the batteries. And whenever you need a sudden jerk of energy at high power, then you can use the supercapacitors from the combination. This is also used in EVs and some applications. The combination of batteries and supercapacitors. Then we have the next question. So this question is, the statement is the use of regenerative braking in electric vehicles is based on what? So we have to see what is the regenerative braking. So now also many electric vehicles or electric cars, they are coming with the regenerative braking. So what happens? Let's say this is your brake of a car. So whenever you are applying the brakes. So if your car is running at some speed, whenever you are applying the brake, in traditional brakes, what happens? You have some brake calipers, and due to use of that friction, the brake calipers will uh, provide friction against the discs attached with the tires. So with the wheels. So what will happen? You will just lose the energy whatever generated due to the friction of the brakes and between the wheels and the calipers of the brakes. So the energy will be lost in traditional cases. But in regenerative braking, instead of the calipers, usually you have another rotor. So whenever you apply a small your light brake or some brake during the running of the car, so first the energy will be transferred to the rotor, and this rotor will rotate. It will absorb the energy of wheels. So your car will slow down and the energy will be the rotor will be connected to some generator, so it will again charge the batteries. So whenever you apply brakes, so it will charge the batteries. So the drawback is whenever you need very sudden braking, then you cannot rely on the rotors just because the rotor will take some time to absorb the energy. So the braking will be not efficient enough. So you need a combination of braking as well as the regenerative braking. So traditional braking with some regenerative braking. So this is used to recharge the batteries, and you can make the life of the battery, or you can make the capacities of battery is very higher, so your mileage will be quite high. So if your car was running for 100 kilometers per charge, so you can, if you have a regenerative braking attached with that, you can go around 120 kilometers per charge, because in immediate whenever you are braking, it will charge your batteries. So the options are: brake pads are removed after each day and attached to the battery for electricity generation. So that is not correct, because the brake pads are not removed. They are there, just it will not be removed. Then second option is braking action rotates the rotor of a generator in the car. So yes, that is correct. So there will be a rotor, then there will be a generator. They are connected. Whenever rotor rotates due to braking, you will get some energy from the generator. Third option is generating heat during operation. The heat is converted to electricity. So that is not correct, because heat is not generated. Just the mechanical energy is transferred from the brakes to, or the wheels to the generator. Then the fourth option is rechargeable batteries in the car are able to accept electricity generated in the car. So that is correct. You have some rechargeable batteries here, so it will just accept the generated energy from the car, from the rotors or from the generator, then it will get recharged. So basically you have, whenever you're braking, you have some kinetic energy. So your kinetic energy from the wheels will convert to the electrical energy. So this is called regenerative braking. Then we have fourth question. So the fourth question is, what are the major replacements done in the conventional capacitors to convert into the supercapacitor? So we have already seen, we will just change the replace the conventional dielectric to electrolyte. So let us see what are the options. So our electrons will be replaced by the ions. So yes, in conventional dielectric, you just have the charges, or as you have the electrons as negative charges. So they will be converted replaced with the ions. Then we have dielectric block by electrolyte. So yes, this is the dielectric block. So you will replace the dielectric block with the electrolyte. Third option is static charge induced by the dynamic motion of charges. So that is correct. Here you have just the static charge, the negative plates, or at the positive plate, you have the opposite charges, so just static here. But in case of supercapacitor, you will have electrolyte solution, so your ions will be moving towards each other. So you have dynamic charges, or you have the motion of charges or charge carriers. So charge carriers are ions there. Then we have fourth option is flat contact surfaces by non-flat contact surfaces. So you have flat contact surface means in a metal plate, you just have everything is quite flat. Flat means there's no porosity, nothing like that. So you just have a 1 by 1 meter size of a plate. But in case of we have discussed that in case of supercapacitors, you will replace your plates with some electrodes. So this may have porous structure, different kind of morphologies of structure. So basically, you will have a non-flat contact surface. So for all options are correct. Then we have the fifth question. Fifth question is, if two energy storage devices have distinctly different. Yes.
Sir, we have not discussed the question number 3.
Question number 3.
Yes,
Okay,
sir.
the
It is
question number
missing.
3. Okay, so we will take at the end. So it
Okay,
might be
sir.
missed somewhere. So it will take at the end. So the question is, if two energy storage devices have distinctly different specific energies. So we have distinctly different specific energies, or the specific energy densities. Then the option is the device with higher specific energy has a higher specific power. So, and the second statement is also similar. This device with higher specific energy has lower specific power. So we cannot comment on the specific power if we have higher or lower values of energy density or the specific energy. So we cannot say this. If you have high specific energy, then your power will also be higher. Or you if you have a high specific energy, power will be lower. So it is not directly related. It depends on the mechanism of the energy storage system. Then third option is specific energy and specific power doesn't necessarily have the same trends across devices. So yeah, that is correct, because they don't rely on each other. Depends on the type of system. The fourth option is the device with higher specific energy will store more energy for the same way. So yeah, that is correct, because energy density means how much energy you can store uh, with the specific amount of, let's say, in volume, or let's say in mass. So whatever energy you have, if you have per kg, then it will be normalized with the weight. If you have the per meter cube, then you it will be normalized with the volume. So the statement is true that it can store more energy, and it depends on the at the same weight it can store more energy if you have the higher specific energy of some system. So power is not related, just the capacities, the specific energies depend on the, sorry, the device with the higher specific energy will store more energy, but the power and specific energies are not relevant to each other. Then we have the sixth question. So this is based on the gears. So in general, there are 4 gears are presented in simplest flywheel setup. If the size of the first gear G1 is smaller than the gear 2 G2, what will happen? So in the case of flywheels, your gears are also important. So what does a gear do? So basically, it can convert your torque in velocities. So sorry, if they can convert the values of torque provided. So let's say you have a smaller gear here. So either your torque will increase or your speed will increase. So torque is basically related to the force. So one thing is speed. If you increase the speed of something, your torque will be reduced. And if you increase the torque means how much force does it have, and the speed will be limited if you increase in the torque. So if you have the driving gear and the driven gear in the same size, so you have basically have the ratio of 1 to 1. So your torque and velocity will be similar for both. But if you have a smaller driven gear and this is your driving gear, so if you have larger driving gear and smaller driven gear, then your speed will be higher, because for one rotation of driving gear it will rotate multiple times. So let's say for one rotation it is rotating once, so for that it is rotating, let's say, 5 times. So you have the ratio of 1/5. So your speed will be very high, but your torque will be reduced. So in similar case, if you have the driven gear is larger, then for one rotation of driving gear, you will have, let's say, half only the rotation of driven gear. So your torque will be generate higher, but your speed will reduce. So basically, if you have G1 is smaller than G2, so if your size is smaller, sorry, if size of G1 is smaller, then RPM will be higher and torque will be smaller. So torque is directly related to the size, but your RPM will be inversely related to the size. So the option 1, G2 will move at the same RPM as G1. So that is incorrect, because we have different sizes. G2 will move at lower RPM than G1. So that is correct. G2 will move at higher RPM. So that is incorrect. We have already seen. And G2 will move at lower RPM at G4. So that is also incorrect, because we don't have any relation directly with G4. So these two options are correct. Sorry. So option 2 and option 4, G2 and G4. Okay, the statement G4 is not given, but you can see the G4 is there, the smaller one. So this is your G2, the G3, G4. So you have to see in what series you are just your torque and speed is converting with each other. So the option 2 and option 4 are correct. Then we have again the question on flywheel. So it is just asking about the energy stored in a flywheel of radius r, rotating velocity v will be proportional to what? So we have already seen the mechanism of a flywheel, and we know the energy is for a flywheel is half I omega square, and we know for a cylinder or for a solid cylinder the moment of inertia is equal to half mr square. So m is the mass, r is the radius of the uh, cylinder. So if you put values of I here, so you will get 1/4 m r square omega square. So basically we got this similar relation that omega square, the energy is proportional to omega square. So the options are square of angular velocity, so that is correct. Square of angular velocity, cube of angular velocity, that is incorrect. Square root of angular velocity, that is incorrect. And velocity raised to the power 0. So that is also incorrect, because power is 2. So you get the first option correct, rest 3 are incorrect. Then again you had a question on MHD based generation devices. So the question is, MSD based generation is typically used in association with a thermal power plant, a wind based power plant, a OTES power plant, a flywheel based generative braking system. So we have already discussed that we need very high temperatures for that. So these kind of high temperatures are achieved only in the thermal power plants. So in thermal power plants, we
Sir,
have lot of
sir,
energy or you lot of high temperatures. So there it can be used.
excuse me, sir, that that page is not
Yes,
visible.
slide is not
That
visible.
slide is not.
Okay, let me just check. Is it visible now?
Sir, question number 8 is not. Question number after
Not on the
7, that is
slide.
9.
Okay, just tell me the question at the later after during our discussion time, then we will discuss that.
Okay, okay.
So this is the question. So since we need very high temperatures to create the plasma or the ionized gases, so these high temperatures are achieved in thermal power plants. So a lot of energy will be wasted there in thermal power plants. So we can use that high temperatures to produce energy with the magnetohydrodynamics power based generators. The option 1 is correct. Then we have the match the followings. We have two columns. So 1.3 volt, 23 volt, atomic number 19, 6,000 RPM. Then we have a flywheel water seeding material. So 60,000 RPM means we are rotating something. So basically the flywheels, and we know that flywheels rotate at very high RPM. So you can see that 60,000 RPM. So it is very high, and the flywheels rotors are quite large and bulky. So you can see how much energy can be stored in the 60,000 RPMs. Then 1.23 volt. This is basically related to water because this 1.23 volt is the voltage at water splits. So splits means this H2O will convert in H2 and O2. So this, if you use the 1.23 volt at some with respect to standard hydrogen electrode, then it will show the water splitting. So this is the related to the water. Then atomic number 19. So basically the seeding material we used in different in magnetic hydrodynamics. So we can use the potassium or cesium. So basically the potassium is the atomic number 19. So that is why we have used, they have shown that it is 19. So it is from the magnetohydrodynamic power generation. So the option 4 is correct out of these four combinations. Then we have few more questions. So let us take a break of 10 minutes. So it is 7:55. So we will start the conversation, the discussion at 8:05.
So 2 questions are left.
Sir,
Which one?
sir, can you repeat the last question number 9?
Question number 9.
9.
So
Yeah,
basically,
this
this
one.
is the they are asking that the MSD devices or MSD based generation is associated with what? So we cannot. We know that
Okay, okay, got it,
we
sir.
need very high
I got
temperatures.
it. Right.
Sorry.
Yes, I got it. I understood, sir. That's okay. I got it then.
Okay.
Sir, 2
So we'll
questions
start the
are left.
discussion at. Yeah, few questions are left. So we will start the discussion after 10 minutes. Then we'll discuss the last remaining questions and whatever was missing.
Okay, sir.
Okay, so let us continue our session. So this is the next question on the based on the fuel cell. So the question is gas flow rate, humidity, temperature, and the gas purity are some of the parameters controlled for testing a fuel cell. So the statement is yeah true. So we know that we have input of gases. So gas flow rates are important and the moisture contents are important. We need low moisture content as our gases should be pure. So gases, the flow rate of gases will need to be optimized. So purity, flow rates, and water content of the gases are need to be optimized, or it should be quite pure. Then the temperatures are, as we know, the temperatures we need some high temperatures for working of a fuel cell. So temperatures are also important parameter. So basically, these are the four are the parameters need to be controlled for testing of fuel cell. So the statement is true. These all parameters are important. Then we have the next question on fuel cell setup used in a lab for lifetime testing and in a real operation can differ in terms of what? So we have a lab uh, fuel cell in a lab and one fuel cell we are using in real life. So the options are use of bottled air versus ambient air. So basically, in case of lab, we have bottled air which is quite pure, and this is at lab grade. So the quality is controlled, and we have very less impurities in that lab in that air. But in case of real life, we may have ambient air or some so air in as source, but it is not at the lab grade, so it may have some impurities, some contaminations. So we need to take care of that. Then rapid change in operating conditions. So yes, in the lab, the temperatures and the operating conditions are maintained. So temperatures, humidities, these all things are controlled. But in real life, we will see a drastic change in temperatures, humidity levels from time to time. So these things need to be, it will impact the efficiency of a fuel cell. So the condition of this condition also be differ. Then the reversal of anode and cathode. So that is not correct because in lab testing or in real life testing, your anode or cathode will not be changed. It will remain the same. Use of hydrogen at the cathode. So we have already seen that we will use hydrogen at anode and oxygen at cathode. So this is also incorrect. So option 1 and 2 are correct. Then we have the third question of PM type fuel cell. So with respect to the gases used as fuel in the anode of a PM fuel cell, which of the following are usually true? So we need to see which statement is true. The first is the gas is dry in order to prevent the catalyst from dissolving. So that is incorrect because we need the catalyst to work. So it's saying that they prevent the catalyst from dissolving. So that is not correct. Then the second option is gas is humid to keep the electrode and the membrane humidified. So that is correct because we need we don't want to completely dry the membranes because the optimized humidity levels or the optimized moisture levels should be maintained. So they it should be humid with some limited humidity levels. Then the third option is the gas used usually with high purity hydrogen. So that is correct. We use very high uh, quality or high purity hydrogen at the anode side. Then the used is usually vaporized petrol. So that is not correct because we are using hydrogen and oxygen. So the option fourth is not correct. So we need basically pure hydrogen oxygen with some moisture content. It should not be very completely dry, and it should be humid enough, have the moisture content enough, which can be which will be effective with the users of catalyst. Then we have Question blank, which gas will lead to poisoning of fuel cell? So we know that hydrogen and oxygen we are directly using, but if you use carbon monoxide gas, it will react with the oxygen and it will make the CO2. So we will get a harmful gases with comparison of CO, with the reaction of CO with oxygen. So it will basically it will poison the fuel cell, and it will not be, uh, if you continuously use carbon monoxide, so it will kill your fuel cell system, because this is very sensitive. The catalysts are very sensitive. So you need optimum hydrogen and oxygen. Although nitrogen will not impact that much, but carbon monoxide will impact a lot. Then we need to match the following. It is based on the fuel cell and internal combustion engine. So this is the internal combustion engine we have already discussed. Basically, we have a combination of fuel and air. Fuel is some organic content. Then you have oxygen in air. It will react. It will give you the CO2 at exhaust. And fuel cell is basically oxygen reacting with hydrogen, giving you H2O. So the H2 plus O2 will go to fuel cell. Then gases are not mixed directly. This is also from the fuel cell, because one gas will go to anode, one gas will be go to cathode. They will mix directly in case of internal combustion engine. Then the electrochemical process, so that is also from the fuel, because fuel is the combustion process. So the combustion process is internal combustion engine, but the fuel cell is in electrochemical process. Then what option we have? Get gases are mixed directly. So here gases are mixed directly, so it is in internal combustion engine. So option, so combination second and third combination, these are correct. Rest option 1 and option 4 are incorrect. Then we have the next question. To increase the efficiency of a fuel cell, so what we need to do? So first option is increase the surface area of the catalyst. So that is correct, because we know the reaction will be happening at the surface of the catalyst. So if we have a higher surface area of a catalyst, so the reaction will be higher. So basically, if you have porous type of structure, or basically you have a higher surface specific area, then your efficiency will be higher. Then increase the three-phase region. So we know the three-phase region, basically anode, AEM, cathode, and it will be solid, gas, and liquid phase. So the three-phase region, if you have the higher region, then your efficiency will be higher. The third option is replace the polymer electrode with the polyethylene membrane, a more commonly available plastic membrane. So do we need a plastic membrane? So that is incorrect, because it will not affect, or it will not increase the efficiency. Just a polymer electrolyte with polyethylene membrane. The polymer electrolyte is used here, not a polyethylene membrane. Then the fourth option is use a platinum rod instead of a perforated platinum. So perforated platinum means you have uh, low density platinum which have higher active sites, or which have higher surface area. If you use the platinum rod, you will see the only the outer exposed area is used or available for the reaction. So you need, so the statement is incorrect, that your use of platinum rod will increase the efficiency. So option 1 and option 2 are correct. Then we have the seventh question. Consider a case of solid oxide fuel cells where we replace a metal wire used in external circuit powered by a fuel cell with a semiconductor based wire. Whatever the possible situation may arise. So you have basically a semiconductor wire instead of a metal wire. So what will happen? So if you have a semiconductor, your electrical conductivity will be lower, and overall efficiency will be lower, and your resistance will be very high with the load. So the options are everything will be all right except the fuel cell operation temperature. So that is incorrect, because everything will not be same. The ionic conduction will increase at a rapid rate. So it will not increase because it doesn't The mobility of ions doesn't depend on the external circuit, but the overall reaction will be slower. So the movement will also be slower. Then the electronic conduction in the outer circuit will be affected. So that is correct because your resistance will increase, conductivity will be lower. So your overall conduction will be affected. Then the more energy will be wasted. So that is incorrect. Sorry, that is correct. Your energy will be wasted because you don't have a metal wire. You have a semiconductor wire with low electrical conductivity. So the option 1 and 2 are not correct, but 3 and 4 are correct. Then we have the option 8. So it says the electrolyte uses in fuel cells and lithium ion batteries are options are same, different, ionic conductors, electronic conductors. So the option 1 is clearly incorrect because the fuel cell and lithium ion batteries works at different mechanism. So your fuel cells use different type of electrolytes, and your lithium ion batteries usually it have some kind of salts of lithium based material. So it will be not be same. Clearly it will be different. And electrolyte, we know that electrolytes are not conductor of electronic the charges, or basically these are not electronic conductors. These are ionic conductors. So their ionic conductivities are quite high, but electronic conductivities are very low. So the option 2 and 3 are correct here. Then we have the ninth question. It says blank helps in cold start because it. So options are proton exchange membrane operates at low temperatures. So we know that proton exchange membranes are working at very low temperature, at room temperatures or low temperatures, in comparison with the solid oxide based fuel cells, which operates at very high temperatures of around 1000 degrees Celsius. So your PMs are basically used for cold start, or you can say for cold start because they operate at cold temperatures. Protection membrane gives the water as byproduct which accelerate the process. So that is not correct because water is not accelerating the process. Then the solid oxide fuel cell cannot be there because they operate at very high temperature, not at low temperature. Then the solid oxide fuel cells gives liquid water as byproduct which accelerate the process. So that is also not correct. So option 1 is correct only. The PEM cells work at low temperatures. Then we have the 10th question. It is for the efficient working of a fuel cell, CO must be, so we have already, which can partially achieved by, so we have already seen that your CO level should be very high. So otherwise it will give the poisoning to the fuel cell. So it should be very less. It should be lower than 50 ppm. So option 1 is saying 50%, lower than 50%. That is clearly not correct because we need 50 ppm. ppm means parts per million. So we need low values lower than 50 ppm. So, and how it is used, how it is removed. So we have already seen in last class the different steps of fuel cell. So we have seen that if you preferentially oxidation reaction is used, so basically it will burn out the CO in presence of oxygen. So CO will react with oxygen, it will give you CO2. So then it will be removed. So CO will be removed in that case. And another technique was the water gas shift reaction. So this reaction also we have seen in the last class. So these are in the initial stages of a fuel cell before fuel is injected in the fuel cells. So option 1 and 2 are not correct, but 3 and 4 are correct. So these were the last 10 questions from the last week. So one announcement is there that we will be having another session or a additional session at the same time on Thursday. And it will be on 18th of April. So if you have any kind of doubts, queries, so I will be there for 7 to 9. So if you have any doubts, I will just suggest you to come early at around 7, and we can have any kind of discussion, whatever doubts you have.
Sir, question number 3 and 8 are remaining.
So 3 and 8, can you just tell me what is the question?
One is the numerical based and the is the theoretical based.
Sorry.
Third question is, may I read?
So if you have the question on your screen, can you share your screen so we can see the question? If it is okay for you.
Okay, sir. Okay, okay.
So I have just pulled up my screen. You can share your screen and we can see the question. What is the question?
Yes, sure, sir. Sir, I hope it is visual.
Yes, yes. So the question 3 is, okay, a person is going from Chennai to Pondicherry in car of 2000 kgs, which is moving with an average speed of 60 kilometers per hour. What will the approximate amount of energy recovered due to regenerative braking if it comes at a full halt at 50% of the energy is recovered during the braking process? So mass is given. So, so you can use the formula of our regenerative braking. So if you got any formula from the class notes, because I have not discussed the exact formula of or exact relation. So basically, you need the formula with relation with the mass and what is the speed, and 50% is the energy recovered during the braking. So do you have any relation from the class notes?
Basically, half MB square kinetic energy, half MB square.
They are
The
using just
effect
the
of,
half mv square. Okay.
yes,
So you just to make the half mv square and the 50% we need to be covered.
but not matching sir answer, sir. By doing this,
So half mv square if you are direct, have you converted in joules or whatever? Because it will be in mass times. Okay, let me try to calculate. So it will be so so basically you get the unit in force. So you need to then convert from the force to whatever you're getting in joules. So it will be. Okay, if it is not matching, what you can do, you can just write this question in the chat box. So in the next class, I will just solve it, and then next class we will see this. Is it okay?
Yes, sir. One more question. Question number 8. In a combined cycle using MSD typically.
In combined cycle using MSD, typically MSD used as a topping cycle, is used as a bottoming cycle. Ionizing additives are added. Ionizing components are actively scrubbed from the flow before enter the MSD region. So cycles, is it topping cycle or let me see the topping and bottom. A combined cycle using MSD.
I think the answer of this question will be A and C.
A and D.
A and C. Ionizing additives are added.
Yeah. So basically, we have multiple cycles in MSD. So in that cycles, you have the coal firing, you have the generator, and you have the MSD itself. So MSD is basically in the topping cycle. Then we have an intermediate cycle. Then we have a bottoming cycle. So MSD in the topping cycle. So option A will be correct. Then ionizing additives are used because we need to improve the ionizing gas concentration. So the agents are or the additives are used. But the option 4 is the components are actively scrubbed from the flow before they enter the MSD region. So it may not be correct, but option 1 C, they should be correct. Okay.
So which option,
So
sir?
the description of MSD is given in the, I have not covered completely. I have just gone over 2, 3 questions, but the description of different cycles are given for MSD. So for whole MSD process, so different cycles are given. So you can just go through and you will get the what is the topping cycle, what is the intermediate cycle, what is the bottoming cycle.
Okay, sir.
And that question you just write in the chat box. So I will just solve and I will just tell you in the next class.
Sir, may I stop the sharing?
Sorry?
May I stop sharing?
Yeah, sure.
Okay, sir. Thank you.
So somehow I finished today's lecture because as I told, my health is not good today. So I am here for more than 30 minutes. So around 9 till 9, I am here. So if you have any doubts and queries, so I will be here to resolve it. So you may ask. If you don't have any queries, so you are free to leave. But I am here till now 9. And next on Thursday, we will meet at the same time. And whatever questions, whatever queries we have, we'll discuss in there.
Sir, this Thursday, next Thursday, next week,
This Thursday, just the
day
day
after
after
tomorrow.
tomorrow. Yes, yes.
Actually, sir, I have paper on 20th, two papers.
So actually, so we will not have a lot of discussion. Means we will not have the discussion beyond the syllabus. We will just looking this same syllabus. And if anybody have any, this is kind of a doubt session. So this is an additional session. So if you like, you may
Okay.
join. So you have the exam on the same time.
No, sir, two papers in morning and evening shift on
Okay.
20th.
So you can just join if you have any doubts for
Okay,
some
sir.
time, whatever time. Let's say if you have 5 or 10 minutes, so if you can join, you just ask your doubts and then you can leave.
Yes,
So it
yes.
is just an additional session, so it will not impact, and we will not cover anything new from the syllabus.
Sir,
Everything will
any
be the
suggestions
previous.
regarding preparation of this subject because multiple select options, right? Choice,
Mhm.
multiple select. It's a very doubtful. Out of four, maybe two, maybe three are correct. If I put any one
Yeah.
wrong, so it gives a negative marks. Negative marks means 0 marks.
Okay.
In case of
So
multiple
the
select options, right?
so this question, these instructions are given to you.
No, no section for exam has been given to us. So we don't know how what is the pattern of the exam, or it will be multiple type or single type questions, or how many questions in the exam. So nothing of that
Yeah,
has been
yes,
said.
sir. What is the pattern of the questions and maybe fill in the
Okay.
blanks or
But the pattern is
multiple.
also not provided to us. But from the last year, I know that you will have some MCQs, some MSQs, and usually there is no negative marking. But if negative marking is there, it will be in the MCQ only, in the multiple choice question. The MSQs usually don't have any negative marking. And you may have some numerical questions, which also will not have the negative marking, and these three type of questions will be there usually, and no description type of question. But your this instruction, it will be either given to you in advance, otherwise in the exam time it will be mentioned if there is any negative marking or not. So so if possible, if there is any practice session, I don't know this time it is there or not, but if you can check the NPTEL side, if there is any practice session, so you can practice and the questions will be similar to that practice session. And whatever the practice session or the assignments you had, the graded assignments, so the questions will be similar to graded assignments, and there also you didn't have the negative marking. So I don't think there will be a negative marking in the exam, but the instruction will be uh, the final. Okay, so
Uh,
either they will give you the instruction, otherwise the question paper will tell you.
Sir, can you share us the this video into the PDF form for session 1 to 12, means assignment 1
Yes,
to
yes. So this is already shared to you. Like
in
I don't
PDF
know,
format, because of
you have the
during the
link or not?
video, because of otherwise we can see the video, then it is so many time duration. If in the PDF form is available, then
Yeah, yeah. So all the links, all the videos or the these PPTs are uploaded to a link. I think you have got the link from the NPTEL site. Otherwise, I will share the link to you. So from the all weeks, from week 1 to week 12, the videos are uploaded at YouTube, and the PPTs, the presentations in PDF format, they are available at the Google Drive. So Google Drive link is, otherwise I will share you the Google Drive link. You
so
can
All
just
the
go.
links are shared. All the links are shared in
Sorry.
NPTEL site. All the links are shared in the NPTEL site for every week. So anybody can download the PPT from there.
So you can download the PPTs from there, right?
Yeah, yeah. I have downloaded all.
Okay, so otherwise I will also share you the link, so you can
sir,
just go
can
through
you
the link.
yes sir, can you share us with?
Okay, so I will share the link in the chat box right now, and you can just use those link to download all the PDF files available.
Yes sir. Okay,
Sir,
thank you.
sir, PDF file regarding a practice set or a whole live session?
No, no, for
PPT.
the live session I'm just saying. For the live session, it is uploaded from my side.
Okay, sir.
So I'm just looking for the website link. I have just given you the link. Just try to open this folder in the Google Drive. The link is in the chat box. So basically, I will just show you. This is the link.
That's something.
Sir, in this only two live session, others are week 1, week 3, week 5.
Only 2 live sessions.
As mentioned in a PDF file.
So can you see on my screen? Is my
Yes,
screen
sir.
visible to you? So these are the all
Yes, sir.
PPTs or either PPTs or in the PDF format. So
same.
these are the uploaded
सर मेरा
link.
अभी
I
चैट
uploaded
बॉक्स ओपन नहीं हो रहा है सर चैट बॉक्स
chat box. Okay.
यस वो ओपन नहीं हो रहा है तो मुझे लिंक कैसे मिलेगी
Chat box अभी भी
It is
ओपन नहीं हुआ.
opening.
नहीं मेरे में नहीं हो रहा है पता नहीं क्या इश्यू है आज अभी हो नहीं रहा है क्योंकि इसलिए
Okay.
मेरे प्रेजेंस नहीं हो रहा है
So one thing you can do, you can just
मोबाइल में
write your email to in the okay, chat box is not opening. So you can share your email or I can mail you your this link. Or one thing. So my email is there, right?
नहीं है मेरे
This is
पास
my
मुझे लिखना
uh,
सर अभी शेयर कीजिए ना मैं लिख लेती हूँ हाँ हो गया ओपन हो गया
हो गया ओपन.
हाँ हो गया अभी पर फिर भी सर आपका ईमेल आईडी मुझे शेयर कर दीजिए
So this is my email address. You can write. It is
ओके ओके
Lalit Bharti 0 Lalit
ओके
Bharti 0 @
ओके 1 मिनट सर स्लाइड जा रही है ठीक है टूल बुक्स दिख रहा है इसमें सर ओके 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 डन 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 ओके
I will just share the link if you need. Okay.
એક અમે પ્લેયર ને ત્યારે રમી આપમાંથી શું જોઈતું હોય 100% સલામતી ને સુરક્ષા જીતેલા પૈસા તરત જ ખાતામાં So thank you, sir, for your valuable time and guidance and teaching us.
Yeah, same. Thank you for the attending the session also.
Sir, if any doubt, I will mail you or by chat because on 20th my paper, two subject papers. So after 20th, I will revise this subject.
Yeah, sure. Also, if you like, yeah, so I'm writing my number also. If you like,
Yes, yes,
if you need have any issues, you can just WhatsApp me on that. So I will be there to assist you.
yes, sir.
Have you got this in chat box?
Uh, yes, sir. Yes, sir.
So if anybody else also, if you need the link from the either the YouTube link or the Drive link for the PPTs, so you can also just ping me on this number and I will send you the link for that.
Yes, I have downloaded all the PDF files and will take print out and will study revise because more questions inside PDF.
Yes.
So once again, very much thank you, sir.
Yeah. Welcome for the appreciation and thank you all.